Hi everyone, in this lecture we will also learn how to solve one more problem from hacker blocks, and this is based upon the concept of binary numbers. So what we are going to do is to solve this challenge on hacker blocks, right? So let's go through the problem. So it says, given a binary number, your task is to help von Neumann to find out the decimal representation. So for example, if you're given this number, this corresponds to 7 in the decimal format, right? So let's have a quick recap how we can convert a number into its decimal format. So suppose you are given a number and we want to convert that number into decimal format. For example, let's say the number is 101. So remember, this number is represented as 101. So at each place we have a corresponding power of 2. So this is 2 raised to the power 0, this is 2 raised to the power 1, this is 2 raised to the power 2, and you can say this is 1, this is 2, this is 4. Your task is to multiply these powers and add them. So when you multiply and add these numbers, so this gives you 4, this gives you 0, and this gives you 1. So this turns out to be 5. So clearly this number we know is 5. So the way we are going to implement is we are going to start by generating powers of 2, and simultaneously we will extract digits from this integer. So this looks like a binary number, but it is given as an integer to us as an input. So number is 101. So what we can do, we can extract the last digit. So if this is number n, we can extract the last digit by using n mod 10. So we get this digit 1. We can multiply it with 2 raised to the power 0, which is 1. So we can take a variable p, which is initially 1. And once we are done with this, we can discard this by doing n equals to n divided by. So it will remove this digit. So you will get 1. And you take a variable answer, you add 1 to your answer. Plus, then you extract the next digit, which is 0. You multiply with the next power. So how do you keep on generating these powers? So clearly it follows a simple pattern. It's you start with 1, you generate 2, you generate 4, you generate 8, you generate 16, and so on, right? The number of times you need to generate this number is same as number of digits in the number, right? While this number is greater than 0. So this number is this remainder, this last digit is 0, you multiply it with the next power, right? So what you will do, p equals to p into 2. So p is 1 here, p becomes 2, so you will get 0. Next time you discard this one by doing n equals to n by 10. You get the last digit by doing n equal to n by n mod 10. And now you will have 1. It will be multiplied with the next power. So how do you get the next power? P equals to p into 2. So you multiply it with 4. So you get this. And finally, you add on these terms to get 5. So what we need to do, we need to write some kind of a loop while n is greater than 0. We need to get this digit remainder. This remainder is n by 10. We need to get this power. So let's say we have the power p, which is initially 1, and we can say answer equal to answer plus remainder into power. And for the next time we can say, okay, we will update our power like this, and we will update our n like this. Okay. So this is the update condition for the while loop, and this is the update condition for power, and so on, right? Finally you can print your answer, right? So we have to follow these steps to convert any number into its decimal format. So let's try to write the code this time directly on hacker blocks. Firstly, we will write for one test case, and then we will do for all, right? So let me say I have a number, let's say which it is 101, and now what I can do is, while this number is greater than 0, okay, and okay, let's do it in id first, or let's do it on hacker blocks only, right? While this number is greater than 0, I can say I have a variable called p, which is 1. in the beginning because it is 2 raised to the power 0, and I have a variable called answer which is 0, and I can say okay, the last digit of my number or the remainder is going to be number mod 10. So I get 0 or 1. So in my answer I will add remainder into whatever the power of 2 I have, and for the next time I will update the power of 2, and I will update my number as n number by 10, right? So that's it, and let's just test for the sample input. So we don't have anything in the sample input as of now because we are just hard coding our input. We want to see what is the answer for 101, or we can say okay, we have a number, we want to see only for one number. How does our code work if we have a single number? So see out answer, right? So let's do compile and test. So let's give sample input as one. Oh, okay, so we missed one thing. So if you get this kind of an error, you have to inspect, right? So it says scene was not declared in the scope. So clearly we have missed one important statement here which says using namespace std, right? So that must be included, and let's run our code again. Okay, so we got answer as 0. Okay, so yes, so another mistake, right? So we are declaring answer inside the loop, right? Which should not be done, right? So this should be only answer because we want to declare our answer only once, and here we will update the same answer, right? So this is a concept of a scope that we will discuss later, but yeah, you should declare one variable only once, right? Okay, now you can see your answer is 5, right? So what we can do is now we can extend this code to handle all the input test cases, right? So if you now carefully read the input format says the first line contains n, the number of binary numbers. Next n lines contain n integers representing binary representation of a number. So instead of doing for just for 101, you have to do it for 4 numbers. So you have in input 4 followed by 4 lines. So each line contains one input and you have to throw one corresponding output, right? So what we will do, we will put another loop, right? Okay, so we will put another loop here, and in that loop we will accept the number. So let me say I have n, which denotes the number of test cases I have, and I will read n, right? And I will put a loop while n is greater than 0. Okay, and for every n I'm going to input a number. I'm going to create a variable p, which is 1. I'm going to create a variable answer, which is 0, and I'm going to extract all the digits for that number, and I'm going to print the answer for every case now, right? And so this goes inside another while loop, and you want this loop to run n times, so you can say n equals to n minus 1. So once you're done with one test case, you can reduce the value of n so that this loop works exactly n times, right? So that is how easy it is to extend this code to for n cases. Now let us test this with the custom input. Okay, this custom input area gives you the functionality to test your logic before making a final submission, right? So code is getting compiled, then we will see the results. Okay. Okay, 5, 15, 6 and 63. So you can match this input with this, match your output with the sample output. So this output is getting matched, which means your output is correct. So once you're sure your output is correct, you can hit the submit button. Okay, so congratulations, we have solved one more challenge, and it's now your turn to solve more challenges on hacker blocks and coding blocks online. Thanks a lot. See you guys in the next part.